We begin our unit with absolute value transformations. Let's first take a look at the absolute value parent function. The absolute value parent function is y equals the absolute value of x. These little symbols right here, these bars, indicate absolute value. Remember, absolute value is the distance away from 0, and it is positive. We also write the absolute value parent function as f of x equals the absolute value of x. Now let's find some points to graph. Always use some easy points, and the easiest points for this particular graph are -2 for x, -1, 0, 1, and 2. So the absolute value of -2 will be +2 because it will always be positive when we evaluate the absolute value. The absolute value of -1 is 1. The absolute value of 0 is 0. The absolute value of 1 is 1. And the absolute value of 2 is 2. Let's graph. This graph is V-shaped. And to help you remember that, remember the absolute value has a V in it. Now let's look for domain and range. Remember XY, check your ID at the door. Helps us to remember that the domain, since it's right underneath the X, are the X values. So let's take our pen and let's find the domain. If I take the graph and arrow down to the x-axis for my graph until I get to the end point, or to the end of the graph, and stop, my domain, or the domain of the graph, is going from 0 to, and there's an arrow here, so this is really an arrow, so it's going from 0 to positive infinity. Now let's look on the left side. Arrow everything down to the x-axis. Again, this graph is going to the left because there's an arrow. I keep going to negative infinity. So the domain is negative infinity to positive infinity, or all real numbers. Now let's look at the range. The R is right underneath the Y in our little saying, so the range are all the Y values. So now let's take our graph and arrow the points towards the y-axis. Now I'm going to continue going up and up and up because this is an arrow, so that means this piece here is also an arrow, so this is positive infinity. Now we do the left side towards the y-axis, and again it's also to positive infinity. So we're going from 0 to positive infinity. The y value at this point is 0. This is also called our starting point. So the range values go from 0, and it's included because this is a solid point, to positive infinity. Before we do transformations, let's look at our transformation, or the general transformations for our absolute value function. Y equals plus or minus a, and instead of f of x, I'm going to use the absolute value symbol, plus or minus b times x plus or minus h, and that's inside the absolute value symbol, plus or minus k outside. And let's talk about our y changes first. For the y change, let's talk about if there's a negative in front. From our last unit, we know that this reflects across the x-axis. Next, let's look at a. Recall, when a is greater than 1, we have a stretch. And when a is between 0 and 1, we have a compression. Now let's look at K. K is our up-down movement. Next, let's look at our x changes. Remember, x is a liar. It tells us to do the opposite of what we really want to do. The negative inside of x reflects across the y-axis. And remember this exception to the liar rule. If we have a b, if b is greater than 1, we have a compression. And if b is between 0 and 1, we have a stretch, because it's the opposite of the way we think. The last part of the x change is h, and h is right-left movement. Let's look at some verbal representations. The graph is reflected across the x-axis. This is vertical movement. It's translated 6 units to the right, so that is horizontal movement, and it's going down 2 units, so that's vertical. Let's write this equation. We have y equals negative times the absolute value of x to represent reflecting across the x-axis. The next item is translating right 6 units. So let's write translating right 6 units. Remember that it's the opposite of the way we think, so for moving right, or if it tells us to go right, we really want to move left. The last item is down 2 units. Y equals negative absolute value of x minus 6 down 2 units, and y is exactly the same. So x is a liar, but y stays the same. The graph is translated up 3 units and left 4 units. Up 3 units is vertical, and left 4 units is horizontal. Let's start with the first transformation. We have y equals the absolute value of x plus 3. The next transformation is left 4, so y equals, this is horizontal movement, so it's x plus 4, because it's the opposite of the way we think. The graph is reflected across the y-axis. We're reflecting across the y-axis. Our negative sign is going to be inside of our function, so this is an x change. It's stretched vertically by 3. That's a y change. Translated left 4 units. This is an x change. And down 1 is a y change. Y equals, we're reflecting across the y-axis, moving horizontally, so it's inside the function. Stretched vertically by 3 is y. Translated left 4 units is x. And remember, we're going left. It says to go left, so we want to actually add 4. And the last transformation that we see is down 1 unit. And this is outside, so it is vertical. The graph is reflected across the x-axis, stretched horizontally by 2, and translated down 5 units and left 2 units. Reflected across the x-axis will give us vertical movement. So this is with the y. So we write this y equals negative times the absolute value of x. Now we're stretched horizontally by 2. That's inside of x. So let's write this part of the equation. Y equals negative horizontally stretched horizontally by 2. Remember, if it's stretched by 2, we want to do the opposite inside. So we want to divide by 2. Translated down 5 units would be written with the 5 outside. We're subtracting 5, and that is actually vertical movement. And now we're translating left 2 units. Because it tells us to go left 2, we're going to add 2 inside. And this is the new equation.